Hey guys, I'm back and I've been away for a while because I just had my second pre-board examinations and let's just pick up from where we left off. We were done with relations from the chapter relation and functions. Let's start with functions, and before we begin, obviously we need to know what a function is. So, a function is said to be a rule or a law, or it could be said as an expression that gives us a relation or a link between two variables, or it shows how one variable is related to the other. So functions are everywhere in maths. You see them everywhere in maths. You write a simple equation, y is equals to mx plus c, then that makes y a function of x, where x is the variable that the function y is defined on. So we all know what functions are from last year. We know what terms related to functions are. We know what domain is, we know what range is, and we know what a codomain is. So today we are going to be discussing types of functions. The two types of functions that are there in our course, they are called one-one and onto functions, or injective and surjective functions. And we basically, in questions, we need to prove that if a function is onto, if a function is one-one. So let us talk about what one-one functions are. So if we were to say what a injective function or a one-one function is, then every function that has a unique image in the range of the function. For example, there is a domain of the function, there is a range of the function. Then the domain, the elements of the domain should each have a unique image in the range of the image. So if I were to say x was a set, or if x was a set of elements x and y was a set of numbers, say 1, 2, and if the function was defined from x to y, and x was related to 1 and y was related to 2, then this could be the most basic way of representing what a one-one function is. Every element has a unique image in the range set. So that is all about what a one-one function is. Now coming on to onto functions. Onto functions, you could say that every element from the y set that we just drew should have a pre-image in the domain set or in the codomain, or the range of the function should be equal to its codomain for the function to be an onto function. So that would be an onto or a surjective function. So now, since we have two types of functions, if a function is both one-one and onto, it is called a bijective function. Now, the primary use of a bijective function is to see if a function is invertible or not. But invertible functions are not in our course of CBSE for 2022-2023. And yet, we could get questions in the CBSE board exams to say that to show if a function is invertible or not. And after that, in this chapter again we have composition of functions, but again that too is not in our course, so we are not going to be discussing that. Binary functions are also, the binary operations are also there in this chapter, and that is also again not in our course. So this pretty much sums up our chapter of relations and functions. And if we were to do some questions with this chapter, so let us just see some questions. Questions I'll do NCERT exercise 1.2. I'll do a question. I'll do the first question. I will do the second question, and I will also do the third question, because the third question is a very favorite question of the board. They usually give the functions which requires breaks to prove one-one, if we have to prove them one-one and onto. For example, they'll give us the mod function, they'll give us the greatest integer function, they'll give us the signum function. All these kinds of functions they might give because it is a very favorite question of the board. So let us start with question number 1. The first question says that show that function defined from R to R. Here R denotes the set of real numbers. I'm sure you all know that. R denotes the set of real numbers, and we have to show that function which is defined from R to R and is given by f of x equals to 1 by x. We have to prove that this is 1, 1 and onto. Let us just begin with the general solution of this question. As we did in relations, we need to do the same thing that we did in functions. First, we will write what we are proving. 1, 1. Either we write 1, 1 or we write injective. So, we have to write it. Then, our first most important statement would be let x1, x2 belong to R. Now, for a 1, 1 function, we assume that fx1 is equals to fx2. The condition for a 1, 1 function actually, which satisfies its injectivity, is called x1 is equals to x2. We prove that x1 is equals to x2, and that is how we get the injectivity of a function. So if we are saying that if this belongs to R, then f of x1 should equal to f of x2. Okay, that is the condition we begin with. If this is equals to this, then implies that 1 by x1 is equals to 1 by x2. Okay, now since both of them are reciprocals, if we again do a further reciprocal, we get x1 is equals to x2, which satisfies our injectivity. So, since it satisfies our injectivity, we can write function is 1, 1. Okay, that sums up the injectivity part. Now let's go on to the surjectivity part. Like I said, injectivity and surjectivity are both synonyms for 1, 1 and onto functions respectively. So if I have to prove that, I will be using them synonymously. Okay, next we have to prove that it is an onto function as well. Okay, so if I have to write it for an onto function, then again I'll write my condition onto or surjectivity, whatever you want to write. Then we say let f of x equals to y. So what we are basically trying to say over here is that we will assume f of x equals to y. Okay, now if f of x equals to y, then it means 1 by x equals to y, or we get the value of x as 1 by y, right? Now if we get this value as 1 by y, then after that what we do to prove it as an onto function, we put the value of x in our function and we try to get the same value. So if I put this, putting x equals to 1 by y in f of x, we get 1 by y is equals to y, and we get y is equals to y, which proves the surjectivity of our function. So that is how our function is a surjective function. Okay, now we have proved both injectivity and surjectivity of our function. Okay, let's move on to the second question. The second question of our NCERT, it has a few subparts. So I will do just the first one. The first one says f defined from n to n and is given by f of x equals to x square. We have to check the injectivity and surjectivity of the function. So again we write our condition, which is 1, 1. Then we check. Now let us say, okay, for this question, let us say that let x1, x2 belong to R. Now if they belong to R, then if this implies that f of x1 equals to f of x2. It implies x1 square is equals to x2 square. Okay. Now if this could imply that x1 is equals to x2, which basically satisfies our condition for injectivity. But if we were to check the solution at the end of our book, then it says that our function is injective. We have proven it to be injective. Now let's talk about its surjectivity. Okay. So if we were to talk about the surjectivity, like we did in the last question, we will first assume f of x equals to y. We write our condition, then we write let f of x equals to y. As we did in relations, there are certain questions in which we need to actually put the values for what we are checking for. For example, in the last question when we did a is less than b square, and we checked it for real numbers, and we did 3, 2 and 2, 1.5. So we checked that for that we're using digits, using real numbers. Here also sometimes we have to check it using real numbers, but here I'll be doing a general solution. So this means x square equals to y, and x is equals to root y. Okay. Now if we say that x is equals to root y, then technically x square could be plus minus y, right? X square could be equal to plus minus y. Now since this means that x square could be equal to plus minus y, now our function is defined from natural numbers to natural numbers. Our domain is natural numbers, range is natural numbers, codomain is natural numbers. So actually over here we say for okay, now let's say we take a number 2, or in fact even 4. Now 4 could have two possible roots, which is plus minus 2. Minus 2 square is equal to 2 square equals to 2. But minus 2 and 2 are not equal, right? So over here, while the codomain includes negative numbers, our domain and range, they only include natural numbers which are positive numbers. So over here actually, if we say that 2 or 4, like we said we took 4, if 4 belongs to n, there is no number in the natural numbers, or there is no other number in the natural numbers which has another root for this. This has two pre-images which is minus 2 and 2, but minus 2 does not belong to n, which is why our function is not an onto function or a surjective function. So what we write over here for the statement, we write that since range not equals to codomain, that is why our function is not onto. We let f of x equals to y. Now say we have 2 belong to n, then no other number in natural numbers that satisfies the condition x square equals to 2 other than 2. But 2 itself has two pre-images, which is plus root 2 and minus root 2. So since minus root 2 does not belong to n, our codomain has negative numbers while our range does not. So our codomain of function not equal to range. Therefore, function is not onto or not surjective. That was easy peasy, right? Let's move on to our next question. The next question is the greatest integer function. Now, the greatest integer function question says that prove that the greatest integer function given by f of x equals to square bracket x is neither 1, 1 or onto. Now we know that it's neither. We have to prove that it's neither. Okay. So let's say our greatest integer function f defined from R to R and given by f of x equals to square bracket x. The square bracket over here, it denotes the greatest integer function. Okay. So if you see a square bracket anywhere on any number, that is the greatest integer function. Now what does the greatest integer function do? I was pretty confused at the beginning of this semester, year when our teacher talked about greatest integer functions, because I had never heard of such a thing. Basically what a greatest integer function is that in this bracket, if you were to write 1.9 or you were to write 1.0, the value of this function would be 1.0. That is what the greatest integer function does. So if any value is there to the nearest integer, it takes the integer which is less than that number. So even if you were to write 2.999998 and you were to write 2.00001, both would have our answers as 2. Okay, so this is the kind of questions where we need to take values. So when we write 1, 1, we say now we write the condition over here a bit changes. For let x1 equals to 1.5 and x2 is equals to 1.9, right? Now if we let it belong to R, right? So if this belongs to R, then f of x1, it implies that f of x1 equals to f of x2, right? Both have the answer 1 equals to 1, right? But x1 not equals to x2. Therefore, function is not 1, 1. Okay. That is all about how we prove the injectivity of the function. Okay. Now let's come on up to the surjectivity of the function. On to now over here, let's check one thing. The range of this function is all real numbers. The codomain of this function, which is the pre-images of this, the codomain of this function is just integers, right? So the codomain equals to only integers, right? Now that means that our range is not equal to our codomain, and since that is not true, therefore our function is not onto either. That is it for today's session. I hope you found it helpful. Any comments and any feedback would be appreciated, and I hope to see you in the next video. Ta-da!